For as long as we have been a species that can think, we have been telling ourselves a story about our own uniqueness. We are the sole bearers of consciousness, the only storytellers, the first and only species on this planet to build a global, technological civilization. This is the story of our primacy, the narrative that places us at the pinnacle of our world's long history. It is a story that is deeply and intuitively comforting. But what if it is wrong? What if the great, silent, and 4.5 billion-year-old book of our planet's history contains other secret chapters? What if another story, the story of a world before ours, has been written and then completely erased by the patient, grinding power of deep time? This journey tonight is a quiet and a serious exploration of one of the most profound and most humbling of all scientific thought experiments. We are going in search of a lost civilization. We are asking the question, is it possible that we were not the first? This is not a story of fantasy or of ancient astronauts. It is a story of a real and a rigorous scientific question, an idea known as the Silurian Hypothesis. It is a thought experiment that asks a simple but deeply challenging question. If an industrial civilization, similar in its energy consumption to our own, had existed on Earth for a few 100,000 years at some point in the deep past, what kind of geological fingerprint would it have left behind? And would that fingerprint, after the immense and destructive passage of tens or even hundreds of millions of years, still be detectable to us today? This is not a search for fossils of cities or for alien tools. It is a search for a chemical scar, a ghostly echo, a subtle, planetary-scale anomaly in the ancient layers of rock. Before we begin our patient search for this lost world, I would love to know from which part of our own modern world you are joining us tonight. Please write your city or country in the comments below. It is a beautiful way to feel our connection as we prepare to look back into the immense silence of our planet's deep past. And if you enjoy these calm and educational journeys into the great what-if questions of science, please consider subscribing to the channel. Your support is the quiet energy that allows these explorations to continue, always calmly, always at the pace of the universe. Our search for a lost civilization is, in a very real sense, a detective story. And like any good detective, before we can look for clues, we must first understand what kind of evidence a suspect would leave behind. The first and most crucial part of our journey, therefore, will be to look in the mirror. We must analyze our own modern industrial age and identify the long-lasting geological fingerprint that we ourselves are currently creating. We will explore the chemical scars of our energy, the strange synthetic fossils of our materials, and the radioactive ashes of our own atomic fire. Then, armed with this guide, we will turn our gaze backwards into the deep and silent and mostly empty pages of the Earth's long history. We will become geological detectives, sifting through the layers of time, looking for any other chapter in our planet's book that reads like our own. The journey will take us to the heart of the greatest mysteries of our planet's past, to ancient global fevers, and to the very limits of our ability to read our own world's story. The question is a profound one, and the answer, whatever it may be, will change our understanding of our own place in the cosmos forever. So, let us now begin our search by first understanding the immense and silent landscape of time in which a lost civilization might be hiding. To begin our quiet and patient search for a world before our own, we must first learn to think on a scale that is almost alien to our human minds. Our own lives unfold over a matter of decades. The history of our civilization, the story of our cities, our empires, and our ideas spans only a few brief millennia. This feels like a long time to us. It is the great and vast landscape of our own history. But to find the space where another civilization might have existed, we must leave this familiar landscape behind. We must learn to navigate a much deeper and much older ocean of time, a concept so vast it is known simply as deep time. The story of our planet is not thousands, but billions of years old, and it is in the immense, silent, and largely empty chapters of this great geological book that we must begin our search. Perhaps the most gentle way to grasp this almost incomprehensible scale is to use a simple analogy. Let us imagine the entire 4.5 billion year history of our planet Earth, from its formation to this present moment, and let us compress it into a single familiar calendar year. In this cosmic calendar, the story begins at the stroke of midnight on January 1st, and the present moment is the final fleeting second before midnight on New Year's Eve. On this scale, the first, simple, single-celled life, the very dawn of biology on our world, does not appear until late March. For the first 3 months of our planet's year, it is a sterile, though beautiful, world of rock and water. The great silence continues for an immense stretch of time. The vast majority of the year, April, May, June, July, August, September, October, is the quiet and patient reign of these simple microbial organisms. They are the great, silent architects of our world, slowly and patiently transforming the atmosphere, preparing the stage for what is to come. It is not until early November that the first complex, multicellular animals finally appear in the oceans. For more than 10 months of our planet's year, there is no life that is more complex than a sponge or a jellyfish. The dinosaurs, the great and famous masters of our world, do not arrive on the scene until the middle of December. They appear around December 13th, and their long and successful reign lasts for about 2 weeks on our cosmic calendar. They vanish from the story in a great, catastrophic impact on the evening of December 26th. In the few, brief days that remain in the year after their extinction, the age of the mammals begins. The first of our own, distant, human-like ancestors do not even begin to walk upright until the afternoon of December 31st. And what of us? What of our own great civilization? The entirety of recorded human history, from the building of the first great pyramids in ancient Egypt, through the rise and fall of the Roman Empire, the age of exploration, the Industrial Revolution, and all the way to the moon landings and the digital age of our present moment. All of it. Every king, every empire, every war, every poem, every scientific discovery, all of it is contained in the last 15 seconds before midnight on New Year's Eve. The life of a single human being on this scale is less than a single heartbeat. This is the great and humbling lesson of deep time. Our presence on this planet is a fleeting and an incredibly recent one. We have appeared in the final, closing moments of a long and epic story. And this reveals the true landscape of our search. The question we are asking is a simple one. In the vast and almost entirely unwritten history of our planet's year, in the long, quiet months of the summer, or the deep, ancient weeks of the autumn, is it possible that another species on another branch of the tree of life achieved intelligence, built a civilization, and then vanished, leaving behind a story that has been lost to the great, silent passage of time? Could there have been another 10 seconds of history, perhaps on the morning of December 15th, or on a quiet afternoon in late November? The canvas of time is certainly vast enough. The silent, empty pages are there. The question now becomes a different one. If a story had been written on one of those ancient pages, would any trace of its ink possibly be able to survive to the present day? We have now stood on the shore of the great dark ocean of deep time. We have compressed the 4.5 billion years of our planet's history into a single cosmic year. And in doing so, we have been humbled by the profound and almost unimaginable brevity of our own existence. We have seen that the history of our world is a book with a vast number of silent and seemingly empty pages, long chapters where another story, the story of a world before ours, could have potentially been written. And this leads us at last to the heart of our journey. We are not the first to ask this strange and beautiful question. In the year 2018, two brilliant scientists, Gavin Schmidt, the director of the NASA Goddard Institute for Space Studies, and Adam Frank, an astrophysicist at the University of Rochester, decided to explore this idea not as a piece of science fiction, but as a serious and rigorous scientific thought experiment. They gave their idea a formal and wonderfully evocative name. They called it the Silurian Hypothesis. The name itself is a quiet and playful nod to the speculative nature of their question. It does not mean that they believed a civilization actually existed during the Silurian period, that ancient time more than 400 million years ago, when the first simple life was just beginning to crawl onto the land. Instead, the name is a reference to a classic episode of the beloved science fiction show Doctor Who, which featured a story about an ancient, intelligent reptilian species called the Silurians, who were said to have ruled the Earth in an age long before the dawn of humankind. By choosing this name, Schmidt and Frank were gently acknowledging the fictional roots of their idea, while at the same time preparing to treat it with the full weight and seriousness of modern science. The motivation for their thought experiment was not, as one might first assume, to go looking for the ruins of an ancient lizard-like civilization. Their true motivation was a profound and a practical one, and it had to do with our search for life on other worlds. As our telescopes, like the James Webb, become more and more powerful, we are on the cusp of being able to analyze the atmospheres of distant exoplanets. And this raises a fascinating question. If we were to look at a distant planet and see an atmosphere that has been strangely altered, perhaps with an unusual amount of a gas like carbon dioxide, our first instinct might be to interpret it as a sign of an active, industrial civilization, a techno-signature. But Schmidt and Frank asked a deeper question. What if what we are seeing is not the signature of a civilization that is alive now, but is instead the long, lingering, geological echo of a civilization that rose and fell millions of years ago? To learn how to read the stories of other worlds, we must first learn to read the deep and often hidden stories of our own. And so, we arrive at the central and beautifully simple question of the Silurian hypothesis. The question is this: if an industrial civilization, similar in its energy consumption to our own, had existed on Earth for a few 100,000 years at some point in the deep past, what kind of geological fingerprint would it have left behind? And would that fingerprint, after the immense and destructive passage of tens or even hundreds of millions of years, still be detectable to us today? This question immediately forces us to shift our perspective on what we are searching for. Our first romantic instinct is to imagine searching for direct evidence. We imagine a team of paleontologists digging in the ancient rock layers and finding the fossilized ruins of a great city, or the metallic shell of a strange and ancient vehicle. But the Silurian hypothesis begins with the humbling and scientifically rigorous assumption that we will almost certainly never find such a thing. As we shall explore in our next chapter, the Earth itself is a powerful and an almost perfect machine for erasing its own past. And so the search is not for artifacts, it is not for fossils. The search is for a trace. It is a search for an indirect chemical scar, a subtle anomaly that has been buried and preserved in the geological record. It is a search for the faint and ghostly chemical echo of a lost industrial age. We can think of this search with another simple analogy. Imagine the Earth is a patient, and a geologist is a doctor, reading that patient's 4.5 billion-year-long medical history, which is written in the layers of sedimentary rock. The doctor is looking for the signs of a brief and a powerful industrial fever that may have occurred in the patient's distant past. The doctor will not find a fossil of the germ that caused the fever. Instead, they will be looking for the symptoms that the fever left behind in the patient's own body. A sudden, sharp spike in the carbon isotope record, a strange deposit of unusual man-made chemicals, a thin layer of radioactive dust, a sudden and unexplained extinction event. The Silurian Hypothesis, then, is not a claim that a lost civilization did exist. It is simply and profoundly a question. The question is, if it had been there, could we even tell? We have now given a name to our beautiful and profound question. The Silurian Hypothesis is not a claim, but a thought experiment, a quiet and rigorous investigation into the deep history of our own world. It asks a simple question. If an industrial civilization existed in the ancient past, could we today even be able to tell? And our first and most natural human response to this question is an equally simple one. We ask, well, why haven't we just found the ruins? Why haven't our paleontologists, in their patient digging, ever uncovered the fossilized remains of a great ancient city, or the strange metallic fossil of an alien tool? This is a perfectly logical question. But to answer it, we must first come to a deep and humbling appreciation for the two great and powerful forces that are constantly working to erase the past. The first is the incredible rarity of a fossil, and the second is the immense, destructive power of the Earth's own geology. Let us first consider the beautiful and almost miraculous process of fossilization. We often think of the fossil record as a complete and detailed library of the history of life. But this is a profound illusion. The fossil record is not a library. It is a single, tattered, and mostly burnt page, rescued from a library that was once unimaginably vast. The truth is that the vast, overwhelming majority of all the living things that have ever existed on this planet, more than 99.9% of them, have vanished without leaving a single physical trace. The normal and almost universal fate of any living thing, from a microbe to a dinosaur, is to die and then to be completely and totally recycled by the ecosystem. It is eaten, it decays, and its atoms are returned to the great common pool of life. For a fossil to form, a series of incredibly rare and unlikely events must occur. An organism must first die, and then it must be buried, and buried very, very quickly in a specific kind of environment. It must be covered in a soft sediment, like mud or silt or sand, that can protect it from the ravages of scavengers and decay. And then it must remain buried, undisturbed, for millions of years, as the immense pressure of the layers above it slowly compresses the sediment into rock, and as the slow, patient percolation of mineral-rich water gradually replaces the organic matter of its body with a hard and permanent stone replica. This process is so incredibly rare that the fossils we do find are a profoundly biased sample of the past. The record is heavily skewed towards creatures that had hard parts, like bones or shells or teeth, as these are the parts that are most likely to survive long enough to be mineralized. And it is heavily skewed towards creatures that lived in environments where rapid burial is common, places like shallow seas and river deltas and ancient lakes. The fossil record is almost completely silent about the creatures that were soft-bodied and the creatures that lived on dry, upland plains or in high mountains, places where erosion, not deposition, is the dominant geological force. Now let us apply this humbling reality to our hypothetical lost civilization. A great city, as solid and as permanent as it may seem to us, is, from a geological perspective, an incredibly fragile and ephemeral thing. It is mostly empty space, and most of the materials we build with, the wood, the plastic, the glass, do not fossilize well, and a civilization that lasts for, say, 200,000 years, the entire time that our own species has existed, would still only occupy a vanishingly thin and temporary layer on the surface of the planet. The chances of a significant portion of one of its cities being located in the exact, perfect geological setting to be gently and completely and rapidly buried in sediment are astronomically and almost prohibitively small. But even if this miracle of preservation were to occur, the fossilized city would then have to survive the second and even more powerful force of erasure, the constant, churning, and violent activity of the Earth's own geology. The surface of our planet is not a static and permanent archive. It is a dynamic and a destructive recycling machine. Any layer of rock that is uplifted to form a mountain is immediately and relentlessly attacked by the forces of erosion, by the patient, grinding power of wind and water and ice. And the ocean floor, where preservation is most likely, is itself being constantly and completely destroyed by the great engine of plate tectonics. The entire floor of our planet's oceans is completely recycled every 200 million years, pulled down into the hot, molten mantle of the Earth in a process known as subduction. Any fossil of a great coastal city from the time of the dinosaurs has, almost certainly, already been melted back into the very substance of the planet itself. The absence of a fossilized city, then, is not the evidence of absence. It is, in fact, the expected outcome. We have now come to accept the first, great, and humbling truth of our search. The immense and relentless power of deep time, with its patient forces of erosion and its great churning engine of plate tectonics, has made the survival of any direct physical evidence of a past civilization an almost impossible dream. The Earth is a master at erasing its own history, and so if we are to have any hope of finding the faint, ghostly echo of a world before ours, we must let go of our romantic search for buried cities and fossilized machines. We must learn to look for a much more subtle and a much more resilient kind of evidence. We must learn to search for a civilization's geological fingerprint. And to understand what such a fingerprint might look like, we must first, with a sense of quiet and objective honesty, turn the scientific lens upon ourselves. We must ask the question, what is the geological fingerprint of our own modern industrial civilization? If we were to vanish from the face of the Earth tomorrow, what scars, what chemical traces, what indelible and long-lasting evidence of our brief and brilliant existence would we leave behind in the rock layers for a future geologist millions of years from now to find? The story of our own impact is now so significant that scientists have given our current era a new and still debated geological name. They call it the Anthropocene, the age of humans. It is the epoch defined by the fact that a single species has become the dominant geological force on the planet, and the fingerprints we are leaving behind are numerous, complex, and profound. The first, and by far the most powerful and unambiguous of these, is the great chemical scar we are leaving in the planet's carbon cycle. Our industrial civilization is powered almost entirely by the burning of fossil fuels. Coal, oil, and natural gas are the compressed and fossilized remains of ancient forests and ancient marine life, organic matter that has been buried for hundreds of millions of years. This ancient, organic carbon has a unique chemical signature: plants, through the process of photosynthesis, have a slight preference for the lighter isotope of carbon, carbon-12, over its slightly heavier sibling, carbon-13. And so, the vast reservoirs of fossil fuels are disproportionately rich in this lighter form of carbon. For the last 2 centuries, we have been excavating this ancient, light carbon and releasing it into the atmosphere at a furious rate. And the result is a massive and incredibly rapid negative spike in the global ratio of carbon-13 to carbon-12. We are, in a very real sense, changing the very taste, the very chemical flavor of the air, the oceans, and the soil. This dramatic and globally distributed isotopic anomaly is the primary and most enduring fingerprint of our industrial existence. It is a chemical scar that will be clearly and easily readable in the sedimentary rock layers for millions of years to come. A second, similar chemical scar is being left in the nitrogen cycle. Our ability to feed a global population of 8 billion people is almost entirely dependent on the use of artificial nitrogen-based fertilizers created through an industrial process known as the Haber-Bosch process. This process has more than doubled the amount of reactive nitrogen in the global ecosystem. And the nitrogen that we produce has a different isotopic signature than the nitrogen that is fixed naturally by microbes. This, too, will leave a clear and lasting chemical fingerprint in the sediments of the deep future. Beyond these isotopic shifts, our age will also be defined by the creation of entirely new and unnatural materials. The most famous of these, of course, is plastic. We have created so much of this durable synthetic material that it has now become a permanent part of our geology. While our plastic bottles and bags will not survive for millions of years in their familiar forms, they will not simply disappear. Over a long and a patient process of heat, of pressure, and of time, as they are buried deeper and deeper in the Earth's crust, these long, complex polymer chains will be broken down and transformed into a new and a strange kind of carbon-rich rock, a kerogen, but one with a chemical structure that is subtly and uniquely different from the kerogens that are formed from natural organic matter. A future geologist, millions of years from now, would be able to drill a core of sedimentary rock and would find, at the layer that corresponds to our time, a thin and globally distributed seam of this strange and synthetic-looking carbon. And finally, we have left a sharp, a definitive, and a completely unmistakable signature of our most powerful technology. The brief period of above-ground nuclear weapons testing in the mid-20th century released a number of specific and entirely artificial radioactive isotopes, like plutonium-244, into the global atmosphere. These heavy radioactive atoms have now settled, like a fine and invisible dust, upon the entire surface of the planet. And because they decay at a very slow and a very predictable rate, this thin radioactive layer will serve as a perfect and an unambiguous time marker in the geological record, a single, sharp line that says with absolute certainty, something intelligent and something powerful was here. This, then, is our ghost, a strange and complex fingerprint written in the language of isotopes, of polymers, and of atoms that should not exist. And now that we know what to look for, our search can truly begin. We have now, in our shared and quiet imagination, completed the first and most crucial step in our great detective story. We have looked in the mirror. We have analyzed the strange, complex, and indelible geological fingerprint that our own modern industrial civilization is, at this very moment, imprinting upon the living rock of our planet. We have learned that the truest and most enduring ghost that we will leave behind is not a monument of stone or a fossil of bone, but a subtle and a pervasive chemical scar. It is a story that will be told in the language of isotopes, of strange man-made polymers and of the faint radioactive ashes of our own atomic fire. This knowledge is our ghost detector. It is our guidebook. And now, armed with this guide, we can at last turn our gaze away from the present and begin our patient and methodical search of the deep geological past. We can begin to look for the faint and ghostly echo of a world before ours. Our search takes us to the great, silent libraries of the Earth's history. These are not buildings with shelves and books. They are the great, exposed cliff faces of the world, the deep canyons carved by ancient rivers, and the long, cylindrical cores of rock that our deep-sea drilling ships pull up from the bottom of the ocean. Each layer of sedimentary rock in these places is a page in the book of time, a story that was written, slowly and patiently, over millions upon millions of years. And the scientists who have learned to read this great stone book are the geologists. A geologist is a time traveler, and their tools are often simple ones: a hammer, a magnifying glass, and a deep and profound sense of the immense, slow, and powerful rhythms of the earth. To search for the ghost of a lost industrial age, the geologist is looking for a very specific kind of story in these layers of rock. Of all the fingerprints that we discussed, the most powerful, the most widespread, and the most likely to survive the ravages of deep time is the great global anomaly in the carbon cycle. As we learned, a civilization that powers itself by burning vast quantities of fossil fuels will release a colossal amount of ancient light, carbon into the atmosphere, leaving behind a sharp and negative spike in the ratio of the carbon-13 isotope. And so, the search becomes a patient and a meticulous one. Geologists take tiny, grain-of-sand-sized samples from each successive layer of rock, and in their laboratories, they use a powerful and a precise machine called a mass spectrometer to measure the carbon isotope ratio that is locked within that ancient stone. Layer by layer, they build a graph, a continuous, high-fidelity recording of the Earth's ancient carbon cycle, stretching back for hundreds of millions of years. And as we look back through this long and detailed history, we can now ask the great question: do we see, at any point in the deep past, a sudden and dramatic spike that looks like the one we are creating today? Do we see the chemical ghost of another Anthropocene? The astonishing, the beautiful, and the deeply mysterious answer is yes. The geological record of our planet is not a smooth and steady line. It is punctuated by a number of strange and often violent events, and the most famous, the most dramatic, and the most eerily familiar of all of these events occurred approximately 56 million years ago. It is a chapter in our planet's history known as the Paleocene-Eocene Thermal Maximum, or the PETM. The story told by the rock layers from this ancient time is a stunning one. At the boundary of these two geological epochs, the record shows a massive and geologically instantaneous negative spike in the carbon isotope ratio. It is a chemical scar that looks for all the world exactly like the one we are creating right now with our own industrial emissions. And this great release of carbon into the atmosphere was accompanied by a profound and a rapid increase in the planet's temperature. The Earth, during the PETM, went into a global fever, with average temperatures rising by a staggering 5 to 8 degrees Celsius. The oceans became warm and acidic, leading to a great and sudden mass extinction event for many of the small, shelled organisms that lived in the deep sea. On the land, the continents were baked by a heat that was far more intense than anything the dinosaurs had ever known. It is a stunning and a deeply mysterious parallel. Here, in the deep past, 56 million years ago, is an event that seems to tick all of the boxes. It is a sudden, a massive, and a global disruption of the carbon cycle, accompanied by a rapid period of global warming and a significant extinction event. It is a geological fingerprint that looks in almost every important detail like the ghost that we are looking for. We have begun our search for the whisper of a lost industrial world, and here, in the ancient stone, we have found what looks for all the world like a clear and a resounding shout. But is it truly the ghost of a lost civilization? Or is there another, a more natural, and a less extraordinary explanation for this great ancient fever? Our quiet and patient search for the ghost of a lost industrial world has led us to a place of beautiful and profound ambiguity. We have found, in the deep time record of our planet's history, a chapter that at first glance looks remarkably like our own. The great global fever of the Paleocene-Eocene thermal maximum, with its massive release of carbon and its subsequent spike in global temperatures, is an eerie and a powerful echo of our own industrial age. And yet, as we have looked closer, we have found that the story is a more complex one. The timescale of this ancient event, unfolding over thousands of years, seems to point not to the sharp, sudden fingerprint of an industrial civilization, but to the slower and more majestic hand of the Earth's own deep geological processes. The prime suspect in our case, the Great Carbon Anomaly, seems to have a natural alibi. And so, our quiet and patient detective story must now turn to a new line of evidence. If the broad, general evidence of a carbon spike is inconclusive, then we must now search for a more specific, a more unique, and a more undeniably unnatural kind of fingerprint. Our own Anthropocene epoch is not just being defined by the carbon we are releasing, it is also being defined by the entirely new, synthetic, and artificial materials that we have created, substances that have never before existed in the 4.5 billion year history of our planet. Let us now search the great stone library of the Earth for the chemical scars of these uniquely industrial products. The first and most obvious of these is plastic. In less than a single century, we have created and distributed such a colossal amount of this durable, versatile, and synthetic material that its fragments are now found in every corner of the globe, from the highest mountain peaks to the deepest ocean trenches. It has become a new and permanent part of our planet's sedimentary system. And so, we can ask the question, what is the ultimate geological fate of this great global layer of plastic? The plastic bottles, the bags, and the fibers that we discard today will, of course, not survive for millions of years in their familiar forms, but they will not simply disappear. Over a long and a patient process of heat, of pressure, and of time, as they are buried deeper and deeper in the Earth's crust, these long, complex polymer chains will be broken down and transformed into a new and a strange kind of carbon-rich rock, a kerogen, but one with a chemical structure that is subtly and uniquely different from the kerogens that are formed from natural organic matter. A future geologist, millions of years from now, would be able to drill a core of sedimentary rock and would find at the layer that corresponds to our time a thin and globally distributed seam of this strange and synthetic-looking carbon. And the question for our own search is a simple one. Have we, in all of our patient drilling and our detailed analysis of the Earth's deep history, ever found such a strange and unnatural layer of carbon? And the quiet and unambiguous answer is no. But our chemical fingerprint is more subtle than just our plastics. Our industrial and our chemical revolutions have created a host of complex and persistent pollutants, molecules that are entirely of our own making. Think of the chlorofluorocarbons, or CFCs, the complex chlorine and fluorine-based molecules that we once used as refrigerants. Think of the incredibly stable and persistent industrial chemicals known as PCBs. Or think of the vast and complex array of artificial steroids, antibiotics, and other pharmaceutical compounds that we have released into the global ecosystem. None of these complex and often halogenated molecules exist in nature, and while they too would be broken down by the heat and the pressure of deep time, they would not vanish without a trace. They would likely leave behind their own unique and deeply unnatural molecular fossils, strange and complex hydrocarbon structures that a future geologist with a sophisticated enough chemical analysis would immediately recognize as being artificial in origin. Have we ever found such strange, telltale, and unnatural molecular structures in the rock layers of the deep past? And once again, the quiet and the patient answer from the geological record is no. And the story continues. Our industrial processes of mining and of smelting have, for the first time in our planet's history, concentrated and distributed vast quantities of heavy metals like lead and mercury and cadmium all across the surface of the globe. And our agricultural revolution, with its use of specific and rare elements like phosphorus and potassium, has also fundamentally altered the chemistry of our planet's soils and its river systems. Each of these activities is leaving its own subtle but potentially detectable elemental or isotopic fingerprint in the sedimentary record, and our patient and ongoing search for a similar anomalous fingerprint from a deep and ancient past has so far come up completely empty. The great stone book of the Earth's history is a vast and a complex one, and we have only just begun to learn how to read its most subtle and intricate chapters. But as of today, in all of our searching, the story that it tells us is a consistent one. It tells a story of a world that has been shaped by the slow and majestic and powerful forces of nature. The chemical scars that we are looking for, the unnatural fingerprints of industry, seem to be, so far, unique to our own present moment. The silence from the deep past continues. But there is one, final and most dramatic of all possible fingerprints that we have yet to search for. It is the most powerful, the most dangerous, and the most unmistakably artificial signature of all. It is the signature of the atom itself. Our quiet and patient search for the ghost of a lost civilization has, so far, led us only to a deeper and more profound silence. We began our investigation by searching for the most powerful and obvious of all industrial fingerprints, the great, global, chemical scar of a disrupted carbon cycle. And there, in the deep past, we found a tantalizing suspect, the Great Planetary Fever of the PETM. But upon closer inspection, we found that this ancient event, as dramatic as it was, likely had a natural geological cause. We then narrowed our search, looking for the more specific and more uniquely unnatural chemical tracers of industry, the ghostly remains of plastics and of persistent man-made pollutants. And once again, the great, silent stone book of the Earth's history revealed no such chapter. And so, we have now come to the final, the most extreme, and the most dramatic of all possible fingerprints. We must now search for the one signature that would be the most unambiguous, the most powerful, and the most undeniably artificial sign of a technologically advanced civilization. We must search for the faint and lingering radioactive echo of the atom itself. Our own brief industrial age has left just such an echo. The period of above-ground nuclear weapons testing in the mid-20th century, as we have learned, released a fine global dusting of unique man-made radioactive isotopes into our atmosphere. This thin radioactive layer will serve as a definitive and an unmistakable time marker in the geological record for many thousands of years to come. But most of the isotopes that we created, like cesium-137, have relatively short half-lives. They will decay into other, stable elements and become effectively undetectable after a few tens of thousands of years. To find the evidence of a nuclear event that may have happened millions or even hundreds of millions of years ago, we would need to look for a much more patient and a much more long-lived kind of radioactive ghost. There are several such isotopes, heavy, man-made elements that do not occur in any significant quantity in nature, and which have half-lives that are measured in the millions of years. Two of the most promising of these are plutonium-244, with a half-life of about 80 million years, and curium-247, with a half-life of about 15.6 million years. These elements are the true potential smoking guns of our search. To find a thin, concentrated, and globally distributed layer of either of these specific isotopes in an ancient stratum of rock would be an almost impossible discovery to explain through any known natural process. It would be a near-definitive sign that an advanced civilization, one that had mastered the incredible power of nuclear fission, had once existed on our world. And so, the search has been undertaken. Scientists have, with incredible precision, analyzed the isotopic composition of deep-sea crusts and ancient sedimentary layers, looking for any anomalous and unexplainable concentrations of these long-lived artificial elements. But before we reveal the results of this search, we must first consider a beautiful and a humbling curveball from the universe. We must consider the fact that nature itself, in one very rare and very specific case, beat us to the discovery of nuclear power. About 2 billion years ago, in a region of what is now Gabon, in Africa, a remarkable and a unique series of events occurred. A natural deposit of uranium ore was, by a stroke of geological luck, incredibly rich in the fissile isotope uranium-235. And when groundwater seeped into this rich deposit, the water acted as a perfect moderator, slowing down the neutrons and allowing a natural, a gentle, and a self-sustaining nuclear fission reaction to begin. For hundreds of thousands of years, this spot on our planet was the site of a true and an entirely natural nuclear reactor. This incredible phenomenon, the Oklo Natural Nuclear Reactor, is a profound and a humbling reminder that nature itself is often more clever and more creative than we can imagine. But the byproducts of this natural reactor were different from the byproducts of our own man-made reactors and weapons. For instance, the specific conditions at Oklo produced virtually no plutonium-244. And so, even with the knowledge that nature itself can create a nuclear reaction, the discovery of a concentrated layer of this specific, long-lived plutonium isotope would still remain a powerful and a deeply mysterious technosignature. And so, we come to the final verdict. In all of our patient searching, in all of our precise and detailed analysis of the deep geological record, have we ever found such a strange and anomalous nuclear layer? The quiet, the patient, and the definitive answer, as of today, is no. The Earth's long and detailed history, as far as we have been able to read it, shows no evidence of a past great nuclear event, either natural or artificial, other than the one at Oklo, the final and most dramatic of all possible ghosts, has not appeared. And we can take a quiet moment to reflect on what it would have meant if we had found such a layer. It would not just have been the signature of an industrial civilization. It would have been the signature of a civilization that had reached a very specific and a very dangerous technological threshold. And given that they are no longer here, and that the only way to create such a global sedimentary layer is through the massive atmospheric detonation of nuclear devices, we would be left to contemplate a very somber and a very quiet possibility. The ultimate and most enduring technosignature of a lost civilization might also be the signature of its own tragic and self-inflicted final chapter. Our quiet and patient search for the ghost of a lost industrial civilization has now reached a provisional and a very quiet conclusion. We have followed the guidelines of the Silurian Hypothesis, and we have searched the great, silent stone book of the Earth for the most likely and enduring of all geological fingerprints. We have looked for the great, anomalous spike in the carbon record. We have searched for the strange and unnatural chemical scars of synthetic pollutants, and we have listened for the faint and long-lived radioactive echo of the atom itself. And in every case, the geological record has given us the same consistent and unambiguous answer. The record is silent. The evidence is absent. As far as our current science is able to tell, the story of an industrial civilization on our planet is a story that has, so far, only been written once. And so it would seem that our journey is over, and that the beautiful and speculative question of the Silurian Hypothesis has been answered with a simple and a resounding no. But the true and most profound purpose of a great thought experiment is not to arrive at a simple answer. It is to give us a new and a more powerful perspective on the questions we are already asking. And the Silurian Hypothesis, when we hold it up to the light of another great cosmic question, gives us a new, a humbling, and a deeply sober way to think about our own place in the universe. It forces us to consider not just the vastness of space, but the even greater and more profound vastness of time. Let us consider for a moment the famous Drake equation. This is not a true mathematical equation to be solved, but is instead another beautiful and powerful thought experiment. It is a simple framework for organizing our own ignorance as we try to estimate the number of intelligent and communicating civilizations that might exist in our galaxy. The equation is a string of probabilities. It asks us to guess at the rate of star formation, the fraction of those stars that have planets, the number of those planets that are habitable, the fraction of those on which life actually arises, the fraction of that life that becomes intelligent, and the fraction of that intelligent life that develops technology that we could detect. But all of these factors are multiplied by one final and crucial term. It is a term represented by the letter L, and L stands for the lifetime, the longevity of a communicating, technological civilization. And of all the great unknowns in this equation, L is the one that is the most mysterious, and the one that we have the most reason to be concerned about. Our own human industrial civilization has existed for only about 300 years. We have had the ability to communicate across the stars with radio telescopes for less than a century. And we have had the technological power to cause our own extinction through nuclear war or through catastrophic climate change for even less time than that. It is a very real and a very sobering possibility that the average value of L for technological civilizations is a tragically and a profoundly short one. This is where the Drake equation and the Silurian Hypothesis beautifully and powerfully intersect. The Drake equation is almost always used to think about the vastness of space. It suggests that if L is short, then the reason the galaxy is so quiet is simply that civilizations are like fireflies in a great dark forest, each one blinking into existence, and then vanishing before another one nearby has a chance to see it. They are separated by the immense distances of space, but the Silurian Hypothesis forces us to apply this same humbling logic to the immense distances of time right here on our own planet. The period of time on Earth during which complex land-based animal life has been possible is, very conservatively, about 400 million years. Let us now imagine that the average lifetime of an industrial civilization, L, is about 100,000 years, which is a very generous estimate. If we were to take that vast 400 million year history of our planet, and if we were to populate it with these brief 100,000 year long civilizations, how many of them could fit, one after the other, without ever overlapping? The simple and staggering answer is 4,000. In the quiet and deep history of our own world, there has been enough time for 4,000 separate, distinct, and non-overlapping industrial civilizations to have risen, to have flourished, and to have vanished so completely that almost no unambiguous trace of them would have survived to the present day. This is the great and humbling perspective that the Silurian Hypothesis gives us. The silence of our planet's deep past, the absence of evidence in the geological record, is not a definitive proof that no one else was ever here. It may simply be a testament to how incredibly brief the lifetime of an industrial civilization is, and how incredibly powerful the patient, grinding, and erasing forces of deep time truly are. Our belief that we are the first may simply be an illusion, an artifact of the immense and unimaginable emptiness of our planet's own deep history. The quiet stone book of the earth may not be empty. It may be a great cosmic graveyard, filled with the faint and now completely unreadable ghosts of 1,000 forgotten, beautiful, and fleeting stories. We have now traveled to the very heart of the Silurian Hypothesis, and we have been met with a profound and a humbling silence. Our search for the geological ghosts of a lost industrial world, the chemical scars of their industry, the isotopic echoes of their energy, the radioactive ashes of their power, has so far revealed no such trace. The great stone book of the earth, as far as we have been able to read it, seems to tell a story of a planet whose industrial age has only occurred once. But our search, as deep and as thorough as it has so far been guided by one great and perhaps very limiting assumption. We have been looking for a ghost that looks like us. We have been searching for the fingerprint of a civilization that is, in its fundamental chemistry and its energy sources, a mirror of our own. But what if this assumption is wrong? What if we have been looking for the wrong kind of ghost entirely? To explore this deeper and stranger possibility, we must now take a journey back even further into the immense abyss of deep time. We must travel back beyond the age of the dinosaurs, beyond the age of the great forests and the first land animals, back to an era when the Earth itself was a profoundly and almost unrecognizably alien world. Let us travel back 2.5 billion years to a pivotal and a dramatic chapter in our planet's history known as the Great Oxidation Event. For the first 2 billion years of its existence, the Earth was a world without free oxygen. Its atmosphere was a thick, hazy, and toxic mixture of nitrogen, of carbon dioxide, and of methane. The sky was likely not blue, but a pale and hazy orange, and the oceans were not blue, but a strange greenish-brown color, rich in dissolved iron. In these oxygen-free oceans, life had already begun and had been thriving for more than 1 billion years. But it was a different kind of life. It was a world of anaerobes, a vast and complex biosphere of microbes whose metabolism was not based on breathing oxygen, but on other more ancient chemical pathways. And then, a new and revolutionary kind of microbe evolved, the cyanobacteria. And these tiny organisms discovered a new and incredibly powerful way to make a living. They learned to use the energy of the sun to split water molecules and create their own food. They had invented the miracle of photosynthesis, and as a byproduct of this miraculous process, they began to release a waste product into the oceans and the atmosphere. That waste product was a highly reactive, a corrosive, and for the anaerobic life of the time, a profoundly poisonous gas. That waste product was oxygen. For hundreds of millions of years, these tiny microbes patiently pumped this toxic gas into the environment. At first, it was all absorbed by the dissolved iron in the oceans, which captured the oxygen and precipitated out, forming the vast, banded iron formations that are the source of most of the iron ore we use today. The Earth, in a very real sense, began to rust. But eventually, all the iron was used up, and the free oxygen began to build up in the atmosphere. This triggered the first and the greatest mass extinction event in the history of our planet. The great, ancient, and dominant anaerobic biosphere was almost completely wiped out by this new poisonous air. This was the oxygen catastrophe, and it was the event that cleared the stage for the evolution of a new and more energetic kind of life, the oxygen-breathing life from which we are ourselves descended. And this ancient, alien history of our own world opens up a new and a fascinating realm for our thought experiment. When we speak of a lost industrial civilization, we have been assuming that it, like us, would have been an oxygen-breathing one, living in the latter, oxygen-rich half of our planet's history. But what if a complex and even an industrial civilization had arisen in that first 2 billion-year-long chapter of life on Earth? What if a civilization of intelligent anaerobes had risen and fallen in the age before the oxygen? What would such a civilization even have looked like? Its biology would have been utterly alien to us, and its technology, and therefore its geological fingerprint, would have been completely different. An industrial civilization without free oxygen cannot have fire in the way that we do. It cannot burn wood, or coal, or oil. The entire foundational technology of combustion, the engine that has driven our own industrial revolution, would have been impossible. Their energy sources would have had to have been something completely different. Perhaps they would have mastered geothermal energy on a colossal scale, tapping directly into the heat of the planet's core. Or perhaps they would have developed a sophisticated understanding of chemical energy, or even an early and a different form of nuclear power. And if their energy sources were different, then the geological scars they left behind would be different too. They would not have left a great negative spike in the carbon-13 record from the burning of fossil fuels. Instead, their ghost might be written in a language that we are not yet able to read. Perhaps it is a strange and an unexplainable anomaly in the sulfur isotope record, or a bizarre and localized deposit of unusual metal ores. The chemical pollutants they might have created would be strange, non-oxidized molecules that we would have no reason to suspect were artificial. We have, in a very real sense, been searching for the echo of a ghost that speaks our own familiar industrial language. But it is possible that the great, silent, stone book of the earth contains a story that is written in a language that is so profoundly and so fundamentally alien that we have not yet even learned how to recognize its letters. We have now traveled to the deepest and most alien frontiers of our own planet's history. Our search for a lost civilization has taken us not just into the familiar past of the dinosaurs, but into the strange and almost unimaginable world of the Precambrian, a time when the very air was a poison to us and the oceans were a different color. We have expanded our search beyond the simple idea of a civilization that looks like us and have opened our minds to the possibility of a ghost that is so profoundly alien that we might not even recognize its language. We have, with a patient and a careful sense of scientific honesty, considered all of these beautiful and mind-expanding possibilities. And now, after this long and exhaustive search, it is time to return to the quiet courtroom of the present moment, to weigh all the evidence we have gathered, and to deliver a verdict. Our great and epic detective story has followed every possible clue. We began by searching for the most direct and romantic form of evidence, the fossilized ruins of a great ancient city, or the strange mineralized remains of an alien tool. And we learned, with a deep and a humbling sense of awe for the power of our own planet, that the Earth itself is an almost perfect machine for erasing its own history. The constant, churning engine of plate tectonics and the slow, patient, grinding power of erosion have made the survival of any such direct evidence over a span of millions of years an almost impossible dream. And so we turned our attention to the more subtle and more enduring evidence, the indirect chemical ghosts that an industrial civilization would leave behind. We searched the great silent stone book of the earth for the most powerful of these fingerprints, the great global chemical scar of a disrupted carbon cycle. And there, in the deep past, we found a tantalizing and an eerie echo of our own time. But upon closer inspection, we found that the timescale of this ancient fever, as rapid as it was still likely 10 times slower than our own, and that the planet itself had a plausible and an entirely natural alibi in the form of immense and prolonged volcanic activity. We continued our search, looking for the more specific and more uniquely unnatural chemical scars. We searched for the ghostly molecular fossils of a past plastic age, or the strange chemical fingerprints of persistent industrial pollutants. And in all of our patient and detailed analysis of the ancient rock layers, we have found no such evidence. And finally, we conducted the most dramatic of all searches. We looked for the long-lived, radioactive ashes of a past atomic age, the unmistakable signature of a civilization that had mastered and perhaps been consumed by the power of the atom. And once again, the deep geological record was profoundly and completely silent. And so, we have arrived at our conclusion. The search is complete, and the verdict, based on all the available evidence that we have, as of today, been able to read from our planet's long and complex history, is a quiet and a simple one. There is, as of now, zero direct and zero indirect evidence to support the Silurian hypothesis. The great and beautiful thought experiment has been conducted, and the result, from the quiet and patient world of geology, is a resounding and an unambiguous no. We must, of course, hold this conclusion with a necessary and a scientific humility. There is a famous and a wise saying in science that the absence of evidence is not the evidence of absence. It is always possible that we have not looked in the right place. It is possible that we have not yet learned how to read the truly alien language of a non-oxygen breathing civilization. It is possible that the ghost of a lost world is still hiding in a chapter of our planet's history that we have not yet been able to open. But in a search like this, where we have a very good and a very clear idea of the kind of massive and globally distributed fingerprint that a planetary-scale industrial civilization must leave behind, and when we have searched for that fingerprint extensively and have not found it, then that absence of evidence begins to become, in itself, a very powerful and a very persuasive piece of evidence. The quiet and overwhelming consensus of the scientific community today is that our own human civilization is indeed the first and the only time that our planet has ever hosted an industrial and a technological age. The story, it seems, has only been written once. Our great and patient search is now complete. We have journeyed through the immense, deep, and silent history of our own world, looking for the faint and ghostly echo of a civilization before ours. We have followed the clues, we have analyzed the evidence, and we have arrived at a quiet and a powerful silence. The geological record of our planet, as far as we have been able to read it, has given us its verdict. The story of an industrial age on Earth, it seems, has only been written once. The case, for now, is closed. And so, it would be easy to conclude that our journey and the beautiful thought experiment of the Silurian hypothesis has been a failure, an interesting idea that has simply led to a dead end. But this would be to miss the true and the much deeper purpose of our exploration. The Silurian hypothesis was never really about finding a lost world of ancient, intelligent reptiles. It's true, and most profound purpose was to hold up a great geological mirror to our own time. The true value of this thought experiment is that it forces us to look at our own civilization in a completely new and deeply humbling light. In our daily lives, we are immersed in the human timescale. We think in terms of days, of weeks, and of years. Our greatest concerns stretch back, perhaps a few generations, and our greatest hopes stretch forward a few generations more. The Silurian Hypothesis asks us to shatter this familiar and comfortable perspective. It asks us to see our own time, our entire modern industrial age, not from the inside, but from the deep and almost eternal perspective of the planet itself. It asks us to see our civilization not as a story of politics, of economics, or of culture, but as a single, planetary-scale geological event. From this immense and dispassionate viewpoint, the entire story of our industrial age, from the first steam engine to this present moment, is a nearly instantaneous and incredibly violent spike in the long and patient history of the Earth. It is a sudden and a dramatic fever, and the fingerprints that we are leaving behind in the stone, the chemical scars that we have just discussed, are the symptoms of this fever. This is the great and sobering mirror that the hypothesis holds up to us. It forces us to confront the legacy that we ourselves are creating. The story of our time, as it will be written in the book of the earth, will not be a story of our poetry, our music, our compassion, or our dreams. The stone is a brutally and a beautifully honest historian. It does not record our intentions. It only records our actions. And so, the story that it will tell of us will be a chemical one. It will be the story of a sudden and a dramatic change in the carbon cycle. A story of the strange, synthetic polymers of our plastic waste. A story of the novel and persistent chemicals of our industries and our agriculture. And a story written in the fate and long-lived radioactive ashes of our own atomic fire. This is our ghost. This is the strange and complex and messy fingerprint that we are, at this very moment, leaving behind for the deep future. And so the thought experiment turns back upon itself, and it asks us the most profound and most challenging question of all. We have just spent our journey searching for the faint and ghostly echo of a lost civilization, and we have found nothing. And the hypothesis gently and quietly asks us to consider why. Perhaps the silence in the geological record is not because an industrial civilization has never arisen before. Perhaps the silence is there because an industrial civilization, by its very nature, is a fleeting and a transient thing. Perhaps the development of the power to reshape a planet on a global scale is a test, a great filter, that very few, if any species, can successfully pass through. The Silurian Hypothesis, then, is the ultimate meditation on the letter L from the Drake equation, the great unknown that represents the lifetime of a civilization. The silence of our planet's deep past is a quiet and a somber warning. It suggests that perhaps the most difficult of all achievements is not the development of intelligence or of technology, but of the wisdom to survive that technology. The question is no longer just about them, a hypothetical civilization from the deep past. It is about us. Will our own brilliant and powerful industrial age be just another brief and anomalous spike in the long history of the Earth? Will a future geologist, 50 million years from now, sift through the rock layers and find only the faint and the puzzling chemical scar of our own brief and vanished story? The true lost civilization that we are searching for, in the end, is our own future self. We have now arrived at the quiet, philosophical heart of our journey. We have followed the faint and ghostly trail of the Silurian Hypothesis into the deep past, and have returned to the present moment with a new and a profound perspective. Our search for a lost civilization has, in the end, become a deep and revealing search into the nature of our own. The great geological mirror that this thought experiment has held up to us has shown us our own, fleeting and powerful. Reflection. It has shown us the chemical scar that our own industrial age is leaving upon the planet. And now, as our exploration draws to its final, quiet close, it is time to ask what is the ultimate and most peaceful wisdom that this entire journey has to teach us. What is the final message that is carried to us on the silent, slow, and deep currents of geological time? The first and most immediate of these lessons is a deep and a necessary humility of the moment. We have seen, through the beautiful and powerful analogy of the cosmic calendar, that our own time on this planet, the entire history of our species and our civilization, is a fleeting and an almost imperceptible sliver at the very end of a long and an epic year. We are, in a very real sense, the children of the last second of December 31st. To truly and deeply understand this is to be freed from the illusion that we are the central and most important characters in the story of this planet. We are not the main characters. We are simply the most recent. The Earth was a vibrant, a complex, and a beautiful world for billions of years before we ever arrived. And it will continue to be a beautiful world for billions of years after we are gone. This perspective is not meant to diminish our own importance. It is meant to place it in its proper and its beautiful context. It is a quiet and a powerful antidote to our own human-centered arrogance. It is a gentle reminder that we are just one brief and beautiful story in a much, much older and much, much grander epic. The second lesson is a quiet meditation on the fragility of complexity. The great and profound silence of the geological record is a powerful testament to just how difficult it is for the evidence of a complex society to survive the patient and grinding forces of the Earth. And this reflects a deeper and more fundamental truth. It is relatively easy for the universe to create simple things. It is much, much harder for it to create and to sustain complex things. A single-celled organism is a miracle of complexity, but it is a robust and a resilient one. A multicellular organism is a miracle of an even greater and more fragile complexity. And a global, technological civilization, with its intricate and interdependent networks of information, of energy, and of society, is perhaps the most complex, and therefore the most fragile, phenomenon we have ever known. The Silurian Hypothesis is a quiet reminder that this intricate and beautiful state of being is not a given. It is not a permanent achievement. It is a precious and a perhaps very temporary condition, one that requires a great deal of wisdom, of foresight, and of care to maintain. And the final and most peaceful of all these lessons is a deep and an abiding respect for the power of the Earth. The true protagonist of our entire long story has not been us, and it has not been a hypothetical lost civilization of the deep past. The true protagonist has always been the planet itself. We have, in our industrial age, become accustomed to a sense of our own, almost godlike power. We can level mountains, we can redirect rivers, we can change the very chemistry of the sky. But our power, as immense as it seems to us, is a loud, a frantic, and a fleeting thing when compared to the deep, the slow, the patient, and the almost unimaginable power of the Earth's own geological forces. The slow, silent dance of the tectonic plates, the patient, grinding work of erosion, the deep and rhythmic breathing of the ice ages. These are the forces that truly shape our world on the grandest of scales. Our own brief and noisy industrial fever is but a momentary interruption in this deep and ancient music. The earth was here long before us, and the earth will be here long after every trace of our own existence has been gently and patiently and completely ground back into dust and into stone. To understand this is to find a deep and a lasting peace. It is to know that all of our own human dramas are unfolding upon a stage that is ancient, that is powerful, and that is, in its own deep way, eternal and serene. Our long and quiet search is now over. We have journeyed into the immense and silent abyss of deep time, looking for the faint, ghostly echo of a world before ours. And we have returned, not with the evidence of a lost civilization, but with a new and a much more profound understanding of our own. The Silurian Hypothesis, in the end, has been a beautiful and a humbling mirror, showing us our own fleeting moment in the sun, as seen from the quiet, patient, and eternal perspective of the planet itself. We have been given the gifts of humility, of fragility, and a deep and abiding respect for the power and the peace of the earth. The story is now told, and its final message is one of deep and profound peace. The great, silent history of the earth is a reminder that our own brief and often noisy lives are but a fleeting whisper in a much grander and more patient story. And so, as you prepare now to let go of the day, you can rest in that immense geological quiet. There are no more mysteries to solve tonight, no more lost worlds to find. There is only the silence, only the calm, and the simple, gentle invitation to drift off into your own deep and peaceful rest. The journey continues, always calmly, always at the pace of the universe.